Okay, so what I wanted to show you, remember I was talking about these inflation fans that keep this greenhouse going? If you look, here's one right here, right? That fan is on 24/7, right?
It's a double layer of plastic.
It's a double layer of plastic, yeah, great insulation, right? So there's 24/7 running this and 24/7 running this. What's controlled by the thermostats are, see this end wall over here? Now that'll drop down. If I tell the thermostat to have that drop, then those fans will cut off and they'll drop down. There's another end wall over here, and in each one of these units, there's a gable vent as well. So, you know, if you look way up here, you see our blower up top there? That's running the gable vent, and that's thermostat controlled, okay? So we want it to be warm in here. We're gonna tell that thing to run until it gets to 80 or whatever in here. We're just trying to get as much heat in here as we can, getting ready for a cold night tonight. Now, what happens when the power goes out? None of these fans have power, right? The gable is gonna fall down, and the sidewalls are gonna fall down, and this is gonna deflate, and that's gonna deflate, and we're gonna have this loose plastic just flapping in the wind. And so what we have is a little battery backup system here that cuts in when the power goes out. Now, how we know the power is out is with a little relay that's in this box. And I'll show you. The coil in this case is always energized. And our battery is on the normally closed contacts. We're breaking the battery circuit to the fans. Comes off the battery, wire goes up to the fans, but passes through this relay. Right now, because this relay is energized, it's latched over, and it's not allowing power to go out to the DC fans that are up here. We've actually got, I don't know if you can actually see them here, but we've got an AC fan and then we've got a DC fan just sitting right next to it. So when the power goes out on the AC fans, the DC fans cut in because that relay loses power. It's not latching anymore. It goes to the normally closed contact and allows power to pass through and comes right off the battery up to the DC fans and they kick in. Guess when I head back in? Okay. Well, it doesn't smell that bad in here because it's all frozen. It's our second Arduino project that we've done out here. We're not actually reversing polarity. We've got one lead that comes off the actuator. It actually came off of an old solar tracking system. But it's 120 volts. And the way this works is it has a neutral, and then it has a line that you energize if you want it to retract, and it has a line that you energize if you want it to extend.
Why you need to reverse.
Yeah.
Ball screw.
Yeah, yeah. It's a linear actuator, and I've got it, and this is actually really unnecessary, but I've got it on this Arduino microcontroller that's in this box. What's really neat about these microcontrollers is the range of stuff that you can do for very little price. This is kind of your gateway to data logging. You know, I can read temperature and humidity off this device right here. And, you know, I can buy my Arduino board, and then I can buy an SD card, they call them a breakout board, and I can actually record data to my SD card. Or I can buy the Ethernet breakout board, and if I knew how to program it, then I could look at this thing from anywhere on the web. I can buy a Wi-Fi enabled board so that I can just run it off the Wi-Fi from our building. I can control it from a telephone. There are a lot of things that you can do with this. What I have done here, you could do with a timer and a thermostat. So I haven't necessarily even put this thing close to its potential. But if you get up here and look at it, you can see right now it's energized, and it takes a reading off of this sensor like every 3 seconds.
Oh.
It's taking a temperature reading, and it's looking at the temperature, and it's saying, is the window closed? Yes, the window's closed. Is the temperature in the range that I want it to be closed? Yes. This window is here for a couple of reasons. It's here to obviously keep the space warmer in the wintertime. We want the window to be open if the temperature is within a range so that flies can naturally come in here, lay their eggs, naturally go out and pupate or do whatever we need. And then we've got this window here again too because this room is passively cooled. So in the summertime it would be too hot if we were to leave this window open. then we want to be able to use our passive cooling system. That it's actually on the back side of this building. So we close the window if it goes above 90 degrees in here, and we close the window if it goes below 55, right? Any other case, this window is going to be open. This Arduino board is taking a measurement on this every 3 seconds.
So the purpose of this whole system here is to maintain, you're interested in not humidity, none of that, but temperature only for the sole purpose of protecting these insects that are creating the grubs and that are creating stuff that you're using in your compost, I
The
imagine.
goal is to keep that open as much as possible.
Open as much as possible unless
So
it's
they
too
can
hot
come
or
in
too
and out,
cold.
fly in and out.
Yep. That's this. You can actually see. I didn't get into how the Arduino is wired up, but I did show you the 2 relays here that show you how to run the closed or the actuator lines.
How many inputs can that take?
Oh man, it's massive. This is called the Mega, Arduino Mega. It has like, I don't know, it's over 20 inputs and over, I think, 16 or out. I don't remember.
Here for a backup system for power to this, if we lose power, do you have a backup system?
We just bought 6 kW of solar, so. it's not
Is that
installed
here
yet.
on the plan, it's on its way?
It's here. Yeah, yeah. That's the wall wart that I was talking about. It's overkill because it's doing what a thermostat and a timer would do for me, right? But it also has the capability. I'll tell you, a dream project is to work out some sort of accounting system. Do all of you guys know about how this system works? You don't? You're basically going to feed this thing food scraps, waste food, meat, carcasses even. And you're literally encouraging the egg of the black soldier fly. You're encouraging the black soldier fly to come in here and lay eggs, hatch in, and they're going to feed off of that waste, and they're going to become little, basically maggots, that when they're ready to pupate, in the wild, what they do is go out and they start climbing trees. What we're doing in here is kind of tricking them. When they're ready to pupate, they climb up this little ramp, and then they fall out that little hole, and then they just fall into a 5-gallon bucket. That maggot is ideal chicken feed, very good fish food. It's a really good animal feed, real high protein, really high fat. The other thing that we have going on here is the specialized lighting. So because we wanted to do this inside, we have to provide them with the right spectrum of UV light, which is actually really hard on your eyes. And yeah, one thing that we've done is added safety switches so that these UV lights will cut on when you close the door. Now the UV lights are on a 24-volt control circuit, which our transformer and our relay are in that box. The switch is up there, and if you were to flip that toggle over and close the door, then these lights will cut on. Now, if you leave that toggle in that position, these lights won't cut on. There you go.
That would be the...
Now, what we're going to actually do is, Pat's picked out some small citrus trees that we're going to move in here so that in the wintertime, they can go up and pupate and hatch out into flies and just recreate the cycle all within this room. We don't even need to open this window.
Do you heat this room in some way?
We do. Yeah, we do. This room actually...
Does that have a control circuit on it also?
It does, yeah. That's all inside our office. All right.
Cool.
Thanks for showing us your class.
Richard, this man wants to know what they need the UV light for. Is it breeding?
Yes, it's a certain cycle in breeding, and it has to be a certain frequency. It replicates what they need in a certain cycle, part of the cycle.
Yeah, so yeah, remember we said our passive cooling system? Okay, these are the pipes that when we added this retaining wall, they went ahead and dug down,
Yeah.
8 feet or so in some places.
That's actually 6, but yeah.
Okay, yeah, 3 of these, and they go all the way out there. That's how long those pipes are.
Oh, that pulls the hot air out and sucks the cold
Yeah.
air in.
It just starts to draft.
Cool.
As long as the doors are closed.
Yeah, as
Yeah.
long as that window's closed.
Yeah.
And then,
Yeah.
and then if that solar doesn't work, the wind will pick up.
That's like the Earthship style.
Well, that's what it is.
Yeah.
The Renko, okay, $50. This is the solar differential control, and okay, what this is actually doing is it's looking at a temperature up in the attic above us. If you guys haven't been here before, something we talked about before, this is a solar attic basically that's has clear panels on the roof. And then when this was built, we spray painted everything inside. It's it's covered with OSB on all faces, and it's spray painted black, and then we're just absorbing all of the sun's energy that we can, and we're cycling that down from this vent, and then it returns through a vent at the bottom of this room. In the back, there's actually a return duct that's built into the exterior wall that returns it back, so it's making this loop all the time. So coming down from the attic hot, moving through the pile, presumably, and then going back up, okay? So that solar kiln, this is controlled by this unit right here. I'll tell you what this is actually doing is the same process in this room behind us. So it's not controlling that fan right now. But so what I have is a reading that says the collector is 40 degrees. Okay, you remember these are built for solar hot water systems. So the tank is 49. So it's 10 degrees cooler up top than it is inside. So we've stopped running the fan, right? Now it would need to get, I can get in here and I can do all kinds of things. I can program the differential of the fan. I probably got it on some sort of a 10-degree deal where it has to be 10 degrees hotter up there before it even cuts on. Another intro, I'll tell you a mistake that I made on these once was trying to control a large load with this. Where the relay ratings on this are only like so much. I want to say it's, here you go, 1 amp. So it's only a 1 amp relay. That's pretty small. And so I wanted to control a pump that would do something more like, 5 amps or whatever. So I went out, I got another relay, an electromechanical relay that would power my 5 amp pump so that I can activate a relay to activate a relay. There's a setting inside of this controller that I called the company, and they called it Poor Man Speed Control, that just pulses the contactor on and off really quickly and simulates a speed control that way so that it can go for, you can force it on to be 100% all the time, or you can dial it down to say like, okay, if we're approaching the bottom of our differential, then cut the fan on, or cut your pump on a little bit slower speed, like 50%. And then as it gets up to a higher differential, if the roof is getting real hot, cut on that pump, let's run it full speed, let's get that heat down in the tank. So a mistake that I made was using that electromechanical relay couldn't chatter like that. Wasn't made to chatter real fast. And I burned up the relay doing that. So what I needed to do was replace that electromechanical relay with a solid state relay that can chatter quickly, right? So just a bit of hard way experience. That's the lesson about solid state relays. Inside of this, there's a relay inside of this box that is a solid state relay that can only handle 1 amp. The old gold line controllers were, I believe they're just like regular electromechanical relays. Okay, it's getting kind of dark. Look inside the Renko. This Renko is looking at the room inside here. There's a sensor that actually moves through the wall and exits on the other side of the wall. So it's 50 degrees in the room just adjacent to us. We built this room as like a curing room. We can control the humidity and the temperature. So if we need things dried, we can put them in there. If we need things maintained at a high humidity, we can also put them in there. Things like sweet potatoes, they want to be cured at a high temperature and a high humidity for a couple of days. Look here, they're pretty simple. There's your transformer. Here's your relay. Okay, so there's your power source. This is 120 volt. I expect it to run at 120 volts. Goes up into there. And there's your relay. If you look closely, you'll see common, normally open and normally closed. Okay? All I'm doing here is switching the thermostat signal. This thermostat signal goes all the way back to the room, way beyond where we just were, and it tells the pump to cut on. And when that pump cuts on, it tells another pump to cut on. And it's like cascades. There may be, 4 pumps that cut on as a result of this thing telling it to cut on.
What's your method of dehumidifying?
Dry air, dry warm air.
Yeah, dry warm air and venting, using the solar to heat it and then venting it out. So you can come in here, these things are really simple. Set it to Fahrenheit. My temp setting is 40. So this is just basically running like a thermostat. If it drops below 40, I want to heat that room up to 40. We're not doing anything with it now. I don't need to do anything but keep it from freezing.
So that vent and the getting rid of the humid air, is that a mechanical fan vent?
It is. It's actually a foundation vent in this room, in here. In this room, it's these fans over here, way up high.
It's probably 60 degrees
Yeah.
relative humidity outside. You're kind of
That's pretty good. It's actually 63. Nice. So this is, remember when I pointed in that room at the Humiditystat that was up on the wall? Okay. Well, I've just decided to move that down here, and I'm not doing anything at all with this Humiditystat. Nothing, except looking at the outside humidity, and then I'm looking at the inside humidity. It's 43 or 45% in here, and it's 63 outside. You know, I mean, that's not great, but it's decent. I'd love to get it down around 30 and maintain it at 30 if I can. That's easy to do in the summertime.
What do you do about the vent if the humidity outside is higher than inside?
Previously, it was not set up that way. Previously, it was just saying, I want it less than 50 in this room. Like, close, if it's greater than 50, close the switch, and let's dehumidify. My only way of dehumidifying was venting, and thus drawing in fresh air. So I never had a control to look at outside and then to look at the, versus the inside. So I'm not actually controlling anything based on the outside, except I'm going on what humidity is usually in this room. And we can step outside real quick. That top little white box is the humidity sensor. And that little homemade box down there, we robbed that switch off of an old dehumidifier, a little like plug-in dehumidifier. And it's the same like that thermostat in the room that has the little bimetal coil where I can get in there and I can move that switch until I hear it click, okay? So that switch right there is only closed if it's less than 55, I think, something like that. So we won't pull in any air at all. If it's greater than 55, we open up the switch and we can't run the vent fans anymore, right? So if it's raining or if it's really early in the morning. Okay, so what I've done in addition to that is now I've put my ventilation fans on a timer. And this timer is the same thing as the $35 one that I showed you. It's I can go in there and we've got it programmed right now to cut on for, I think, 30 minutes, 4 times a day, if it's less than 55% humidity outside, okay? So what we're expecting to happen is a dry-ish day outside, and if you get on the weather report or we use Wonderground, and if you look on there, you can see the forecast for the relative humidity, and you can see it's always high in the morning, and then it dips way down, gets real nice and dry after about 11 a.m. until about 5 p.m. So at 11 a.m., I have my fan cut on for 30 minutes. And then I cut it off. I wait 2 hours for this room to heat back up from the solar. And then I run that fan again for 30 minutes. And then I wait 2 hours and let this room heat up. And then I run that fan again one more time for 30 minutes. Right? I think we might do that actually 4 times. And then we vent right before the end of the day so that all the moisture in this room goes out and it doesn't stay in this room and condense and do whatever when it cools off at night.
You're never removing any liquid water. It's all
Vapor. Yeah, and it's
Dampness.
airborne because this room is hotter. It can hold more water than if it wasn't hot. I can open this up and show you guys how it's wired. It's literally the same thing. It's a normally open and normally closed single pole double throw relay.
So that area you've got upstairs there, which is really collecting solar heat, really.
Yeah.
And it's a dry heat, I would imagine. Does that sound right or not really? No, it's very humid.
It's taking ambient air, right? And it's just heating it up and dropping
It's actually
relative humidity.
It's a pretty humid heat.
It's the same.
It's taking this air, so it's actually pretty wet if it's hot, it's driving, if we bring in a fresh pack of green slabwood in here, it's actually pretty, and that's been a pretty good problem for
Air
us.
can maintain less moisture in it. So as the temperature goes up, relative humidity.
Yeah, it's been a real problem with us, is if we're not ventilating enough, then our relative humidity goes up in this room, and then at night, it condenses on those clear panels.
You're pulling the moisture out of all this wood.
Yeah, and it's actually led to some real problems, like screws popping out of the clear panels. The purlins up there are starting to rot a little bit. Something we're trying to pay really close attention
The
to.
humidity in the air to extract the moisture out of the wood and then pump it out.
This is a similar design for people who need to dry like lumber down below ambient. So I mean, if you need to get your firewood, what is it, like 30% moisture content is like fiber saturation point?
19 to 20. 19 is a Lowe's lumberyard MC moisture content. 25 is fine for firewood, but there's much better designs, direct sunlight designs with curtains that are perfect for firewood and for hobby. And
Just
for
leaving it outside in the stacks.
Yeah, air drying for a certain amount of time is really the ideal way to get your firewood down. Then we ran some experiments and really learned that it didn't actually really help that much. Yeah, y'all want to go inside? Really important, we all know how to use a multimeter before we get out of here. This iFixit, what they do is collect repair manuals, and people contribute repair manuals to them. And they're trying to be just like a one-stop for all repair manuals. And they're actually doing little short walkthroughs on how to repair things. It's kind of neat. When you go to click on the iFixit, they're doing a petition right now to enact legislation that makes all products have to be repairable by the owner. You can measure a very small amount of amperage through your meter. When you measure amperage, you actually have to break the circuit and measure in between 2 points. You can't. It's not like measuring voltage where you can measure by just touching it somewhere. You have to pull the wire off, put this on the wire, and put this on the other, where the wire would land. You can't do that because we're talking about too much current. That's really for very fine electronics work. What I would recommend is buying a meter that has a clamp, and this clamp is how we measure amperage. We're selecting range when we measure amperage on this meter in particular. If it's 2 amps or less, click it here. 20 amps or less, or 100 amps or less, click it up here. Start high and then work low. We're going to pull half an amp on this light bulb, so if I want to check it, I just click it on the 2, because we're going to measure 2 amps or less, and I just click it around that wire, right? And then it'll measure the amp. The AC symbol is sine wave, and then the DC symbol is the straight line with the dotted line underneath it. Overcurrent protection is a huge topic. This is just like talking about motors before. For our purposes, most of what we're going to do is just replacing an existing blown fuse. And you do need to replace it with an identical type. If you don't know what a fuse is, think of it as a built-in weak link. It's going to fail and open up your circuit before your wires melt or before the equipment that it's protecting burns up. We kind of use fuse and a lot of times interchangeably with breaker, like our breaker panel. If we're plugging into an outlet that's on a 15 amp breaker, it's going to trip the breaker if you have more than a 15 amp pull. So a short circuit is who knows? It's a massive amount of pull, and it's going to trip the breaker if you have a short circuit. We were talking about interrupting rating earlier. That's where it gets a little bit out of my league in terms of selecting fuses, is sizing it based on its interrupting rating. If you get an interrupting rating that's too small on your fuse, then you can actually just arc across your fuse and it won't really protect anything. Motors do need overload protection. That's why I was saying let's look for one with a built-in thermal protection. Generally, we're talking about time delay fuses for motors and fast-acting fuses for resistive loads. One thing we do need to really understand, though, is ampacity. If you're replacing a wire, say you've got a broken wire on a power cord or a broken wire in your appliance that you're replacing or something, look for the same type of wire and replace it with that same type, same size or larger. Each wire is capable of carrying a certain amount of amperage before it's going to overheat through the resistance, the friction inside of that wire will cause the insulation to melt. So general rule of thumb is a 15 amp breaker you need a 14 gauge wire or larger, right? A 20 amp breaker, you need a 12 gauge wire or larger. And it goes up. I think it's a 30 amp breaker, you need a number 10. You're going to see a 30 amp breaker in your water heater if you have an electric water heater. You'll see a 30 amp breaker and a number 10 wire that feeds your water heater. Might be the same with your well pump. I don't know what typical well pump breakers are going to be, but it's going to be a larger wire with a larger breaker. Don't go fixing your water heater with a 12 gauge wire, or don't go working on your well pump circuit with anything less than, assume it's number 10. Maybe number 8, I don't know. As you go down in gauge, a 4 gauge wire is much larger than a 14 gauge wire. I think an 18 gauge wire is good for 5 amps. I'm not positive about that. But you can look up these tables. You can Google it if you don't know. You can say, what size wire can I use? Also pay attention to the insulation type of wire. Some wires are really heavily insulated and will likely get hotter before ones that aren't heavily insulated. You got to pay attention to how many wires are bundled together. You got to pay attention if it can be buried or not, if this wire can be left out in the UV light. There are so many different factors that go into selecting a wire. If you don't know, don't get ahead of yourself. Call a friend who does know. Do some real good research on your own and figure out what's good. Aluminum wire typically has a lower ampacity than copper wire. You got to go up in size if you want to use an aluminum wire. Yeah, we use aluminum wire sometimes as an underground wire in our solar systems that we would do.
The aluminum will swell and contract much greater than copper. So what happens is it loosens the terminals, and that's where you get your arc and your fires. That's why they stopped putting it in the houses. And the distance too. I don't know if you mentioned, is that part of the discussion? The distance affects the amperage.
Sure, especially in DC circuits. But yeah, also in AC circuits, extremely long extension cords will increase the resistance quite a bit. Let's talk about some controllers, just specialty controllers, and we'll get into this. These are some of my favorites. This is the Pico TF115. This is the thermostat that we have in the greenhouses. This is when we say it controls the gable vents. It has normally open and normally closed leads. It's a line voltage thermostat, so you can send 120 volts to it and switch 120 volts, just like a light switch. You got power that comes in. It has a little like black lead that hangs down. Power goes into it. You got your switch inside of it that, depending on where you set the dial on that thermostat, it's either out on here or it's out on here. And what's interesting about that is that, say you set it for 60. Anything above 60, this line is going to be hot. This line is not. Anything when it drops below 60, this line becomes hot. This one isn't. So you can use that thermostat for heating or cooling applications, right? So if you want something if you want to run a fan and cool your greenhouse down to 60, then wire it up on that. If you want to use a heater and heat your greenhouse up to 60, then wire it out on that, right? Real simple. What's great about this is the housing, NEMA 4X. That's something we haven't even touched on yet, but it's really important when, especially talking about farm and agricultural applications. A lot of this stuff is not going to go inside of a conditioned space. The NEMA 4X means that you can spray it down with water. It's not submergible. You can't put it underwater, but you can spray it with water. So your irrigation system in your greenhouse, whatever it is you're doing, isn't going to hurt this thing. And it has this coil up here. That's a bimetallic coil. That's essentially the thermostat device. It's working on 2 different materials in there that expand at different rates and opens or closes the contact based on whether or not those coils are touching. Requires no outside power source, too. Plug it into the wall, and then you plug in whatever it is you want to control into that side of it. Right? Pre-wired. If you listen carefully. That's the switch. That's where it's either on or off. This would be an open on rise thermostat. So it opens after it hits the temperature, right? So the circuit is closed. Power passes through this thing when we're below our set point, right? So if you hear that click, it means power's not passing through it. Below that click, power is passing through it.
That one control would work well in a greenhouse and be able to control both the heating side of things as well as the cooling side of things. Whether it be a cooling fan versus a, maybe tripping a relay that's going to initiate your heating.
There you go.
Is that right?
Yeah.
Is that right? Okay.
So an element there you have to be concerned with is it doesn't cycle, right? So hot to cold to hot to cold. There has to be some hysteresis in the cycle.
Yeah, deadpan.
So you don't get into a control loop where it heats and then it goes up and then
I
it
see.
cools.
Yeah, you're gonna have your heater on this side and your air conditioner over here, and it's gonna on, fighting itself. It may have some sort of a built-in differential there. I'm not sure. I think I actually printed off the spec sheets for this. I'll pass that around. Here you go. So you'll get one of these if you buy it. You'll also get one of these if you just Google it. So looking for a spec sheet is always a good idea, right? Really flush out the details on what it is you're getting. Let's see if we can find a built-in differential if it tells you anything about that. 3 degrees Fahrenheit, nominal separation between rise and fall.
You really probably need like 2 thermostats. One cuts on heat at, say, 40 degrees, and maybe cuts on air conditioning at 90.
Yeah.
Well,
Or
Sure.
so I think when it says 3 degrees there, it's 60 degrees going up, and 60 or 57 degrees coming down. Because
Yeah.
it's cooling, so there's a 3-degree difference of when it opens and closes, depending on if it's heating or if it's cooling.
Point is, you're not going to use that to heat and cool. You're going to use that to do one or the other. Remember, in our greenhouse, we've got our passive cooling system, right? So when we get up to a certain temperature, that switch opens, and the gable vent and the sidewall vent fans stop running, and everything falls down, right? And then we're passively cooling. Okay, we don't have an active cooling system in that greenhouse.
Then what I was saying before wouldn't really be the case. You would not be able to use that to do both the heating side and the cooling side. Then you're saying, right?
Yeah, you would use this to do either or.
You could do either or, but not both.
Yeah.
And what's the double throw intended for then? I understand a single pole, but if it's double throw, wouldn't it mean that it would in fact work like a fan to cool something if it gets a little too hot? Versus
The switch style is the single pole and double throw. It can either, right? Yeah, it can land on 2 different places. Right, so they do that so that you can use the same unit to control heating or cooling. Yeah, so you don't have to buy a specific unit. Yeah, like this plug-in thermostat only works one direction. This is open on rise or open on fall. Programmable thermostats, this is probably what most of you guys have in your house. And that's what mine looks like. Typically powered with 24 volts, much more sophisticated operation, programmable, the whole deal. Now, what's the problem with this? These wouldn't have the environmental rating to put in your greenhouse. And another problem with some of these is that if you want to put them in your greenhouse and you want to build a little box around them to protect them from the weather, their sensor is inside of that unit. And it's measuring the temperature inside that box now. So what you want to look for is one with a remote sensor, that you can put that sensor anywhere. We have thermostats that control the radiant floor tubing here. And that same thermostat will control 2 devices, actually. We used to have heaters that hang in the corner of this room. That one thermostat will look at the air temperature remotely, and it'll look at the slab temperature. Right? So what it'll do is it has 2 relay outputs, and it's looking at temperature 1, which is the floor. We're going to heat the floor, and if we can't get the room up to temperature by heating the floor alone, then we're going to kick on what they call stage 2 heating, and we're going to kick on the air fans. Just an example of a nice thermostat. We paid for that thermostat. Techmar offers a lot of hydronic heating controls. Definitely a good place to look if you're looking into doing some sort of creative thermostat work.
Basic same circuit is if your heat pump circuit can't maintain the temperature, it turns on an electric grid heater. It's kind of the same system.
Yep, same deal. So this Honeywell thermostat does just that. This is like the same heat pump thermostat that I was talking about earlier that's got the orange wire that turns on the compressor, the yellow wire that does the reversing valve, the red wire that's always 24 volts. I think the green wire, if you want to just turn on the fan, apply 24 volts on your green wire. That'll just turn on your fan. So, I run the wood stove at my house, but oftentimes I'll just turn on the fan. And, my living room gets crazy hot and the room's off to the side. Turn on the fan and I just distribute that heat all around my house. Unconventional installation, you've got to pay close attention to these environmental ratings or you'll get beat by that. Here's a unit that takes a lot of high humidity, up to 95%. This is just like the Penske truck. Now that you've seen it, you're going to see it everywhere. This is the Renko, and we were talking about the thermostat out there that has that built-in differential of 3 degrees. Well, this has a differential that you can set, and you can set this thing to open on rise or close on rise. Open on rise for heating applications, the switch opens after you hit your set point. Close on rise, the switch closes after you hit your set point. Programmable differential means that you can tell this thing to heat the room to 70, and let's put a 10-degree differential in it. So it's going to heat the room to 70, and then it's going to allow the room to cool to 60, and then it's going to kick back in and heat the room to 70, right? That would be the differential. You can see the graph there. The example of you doing this is the solar heating systems that we did a lot of. We do a built-in differential on the solar heating systems. We're looking at the temperature of the collector and the temperature of the tank. And so when the pump isn't running, when the temperatures are close together, the tank and the roof, then we're not running the pump. But when the roof gets, say, 15 degrees hotter than the tank, then we're going to cut the pump on. And that 15, as soon as that water starts circulating, that 15 is going to drop, right? And we want to have a built-in differential there so that it doesn't drop immediately and then cut off. Cut on, cut off, cut on, and cut off, and cut on. That's called short cycling when it's this really quick repetitive action. And we do a built-in differential so that it has to be 20 degrees hotter before it cuts on, and then it cools down to where it's only 5 degrees hotter, and then it cuts off, right? So that would be a 15-degree differential. Does that make sense? Heating mode, if you set it up to 70, it's going to heat to 70, and then it's going to turn off, and then it's going to turn back on when it gets to 60 if you have a 10-degree differential. Another way to think about this is high and low mass systems. A high mass system is going to take a long time to heat up. It's going to take a long time to cool down. So you can get away with a smaller differential in a high mass system. On this floor, we might have a 2-degree differential, right? But in the air, we're going to have a 10-degree differential. Okay, here's a 2-stage control. Renko offers another product that's a 2-stage control that has what they call a built-in deadband. Now, this is what you need if you want to use one unit to control an AC and a heating system. And you need to have an acceptable deadband. Deadband is that space where it's not heating or cooling. Another problem with this Renko is that you're limited to one single sensor that does all of this. There's a lot of applications where you want to cool in one place and heat up in another place. Now, we'll tell you that this Renko, the single-stage Renko is about $50, and the dual-stage Renko is like $100. So if you want one with 2 sensors, just get 2 single Renkos. Humidistat. This is just an example of a humidistat. This is one that Richard's going to be using on his germination chamber. Low cost on Amazon. These are just basically doing the same thing as a thermostat, measuring relative humidity somehow. Relative humidity is the temperature compensated humidity of the room. This one's very cheap, pre-wired outlet. Pretty wide range, 1 to 100%. I'll tell you a mistake that we made when we built this place. We actually have a humidistat up on the wall, but that's a residential humidistat. Now, we put it there because it doesn't have a remote sensor. It's actually built in, and we had to put it somewhere, so we put it there. I would have loved to have a remote sensor with a cable that runs all the way into our office where I can control it, but it was a mistake we made early on. Range on that is what you would normally expect inside of a house. If you're using that to control a humidification system or dehumidifier, 35 to 80. That's all our range. Now, I would love for this room to go well below 35 RH. The room next door, a kiln. But, kind of forced my hand to do nothing at 35 or lower. We actually cut our fans off at that point. Last thing we'll do is walk over into the other kiln. I'll show you what we've done to change our dehumidification system in there.
And the kiln is just to dry the wood.
Just to dry the wood prior to going in the retorts. Yep. This is one of my favorite timers. It's $35. This little $35 timer is what we use to control that giant 20 horsepower mixer. It's the TM619. You can Google that number and you'll come across, like, I don't know, 100 different places that'll sell it. Timer Co. is the company that I have bought it from, and we'll buy it again, I'm sure. 8 different settings, programmable on-off settings. You can go down to the second, or you can go up to the hour. 7 times a day, you can have it cut on from 12 o'clock to 12 o'clock in 1 second. What we're doing next door in the kiln is we're using one of these timers and a dehumidistat, and we're using, we're going to pulse our fans on and off throughout the day if the air outside is drier than what it is in the kiln. Okay? So I'll show you how we did that. Yeah, huge range, battery backup. It actually retains the current time. That's actually really an important thing to pay attention to, is make sure that when the power just flickers, it's not going to reset the time. Like a Christmas tree timer, actually, if the power's off, a lot of those Christmas tree timers will just stop. They need power to keep that dial spinning at 24 hours a day, right? So at least we got something that won't do that. It will retain its memory. You guys recognize this? It's a relay, more or less. Power goes in, powers the timer. You can get this at 12 volts, 24, 120, or 240 AC. But you do have to spec that when you order it. You got to know ahead of time what your application is. And it's just that same single pole, double throw relay. You know, a lot of people use this for animal feed dispensing. They'll control a little actuator that just opens up for 10 seconds and drops food into a bowl. Your chicken coop door, you can have your chicken coop door rise at, 7 a.m. and close at 7 p.m. or whatever you want. This little thing is nice for those really simple timed operations. It's a weekly timer. You can have it cut on only on the weekends. You can have it cut on Monday through Friday, whatever. Here's a different kind of timer. This is the Peltec 102. Mostly really happy with this one because of its wide capability. A lot of different ways that you can use this. It's a single relay. Again, it's the single pole double throw where it has a normally open and a normally closed contact. This is called a repeat cycle timer. You can program it to have an on time, and you can program it to have an off time. This is like coarse and fine tuning for its on time. And then down below, it's coarse and fine tuning for its off time. I'll tell you where we use this, is that we did a little experiment using our wood vinegar. And we did a little germination trial where we did different dilutions of wood vinegar on water, and we soaked the seeds, and we tried to see if wood vinegar enhances germination. What we needed was something that could water the trays on a regular basis. So all I had was a little utility pump right here that would pump out of one of the IBC totes, and I had a timer inside this box. I would run the utility pump for 5 minutes every 8 hours or something. I don't remember the interval that we set up, but we just watched it and we decided, okay, now is our media wet? At what point is it going to dry off? Let's have it spray it until it's saturated, and let's have it not cut on until before it dries out. So that's one way to use a repeat cycle timer. Another way we use this timer, we have a gasification generator system that we haven't totally debugged yet. One issue we were having was bridging inside of the hopper. This is a machine that takes wood chips, gasifies the wood chips, cleans the gas, and sends it in through an internal combustion engine. And the bridging inside of the chamber was an issue with our wood chips. So what we did, Evan, this is one of Evan's first projects out here, was take a 12-volt drill and we built a little agitator device, and we set it up so that it was gas tight, and we hooked up the 12-volt drill, and we set it on a timer. We said, when the system is running, every 5 minutes, we'll turn on the drill for 10 seconds or something. I don't remember. So that little drill had this little agitator bar that just knocked down the wood chips, so that we never had that bridging issue anymore. Pretty clever. Yeah. I'm sure you can think of a million ways to use this. I'll tell you one other way we use it is on our retort alarm system. So one of the first things we did getting into controlling things out here was look at an overheat prevention alarm and an overflow prevention alarm on our retort system. We're measuring the temperature underneath the retorts all the time. And we have temperature controllers that look at that temperature and close a relay if it goes above that temperature. When we close that relay, 24 volts passes through and goes up to a relay, another relay that turns on our stoplight. Big red light turns on. When that red light turns on, it triggers a timer that then takes pulses, our buzzer, on and off, right? So originally we started with the red light because when we're standing around, we thought we'd be able to see the red light from anywhere. That clearly you can't see the red light. Even if we're here, we can't tell the red light's on. But we can hear that buzzer from anywhere within like a 200 feet radius. And everybody else, even at the church, I'm sure they can hear the buzzer all the time. But you know, when we originally hooked it up, it was way overkill. It's like, until you get over there and solve the problem. So what we have it now is we used a timer to say, wait 20 seconds. You know, instead of just being blasting us all the time with the timer. So that's another way. We didn't actually use the Peltec there, but we used a really similar timer that had an adjustable on and an adjustable off time. That timer was, I think, some sort of a Dayton timer. It was an older model. New, that timer cost 120 bucks. New, this one cost about $50. Ranged from 0.1 seconds to 100 days. You could set your on time for 100 days. Every 100 days, you could have it go boop. Yeah, a lot of these timers, if you're not careful, what you'll get is one programmable time. And then you have to work off that one program. So what I have here on the demo board is a timer that we got from the junkyard that has a single programmable time. So what it'll do, it just blips at one interval. It has to be on for a second, has to be off for that equal amount of on time, right? So that would be useful for our buzzer too. I mean, I suppose it would. It would be more like meh, meh, meh. Now, there's some interesting things about these timers too that, you know, it's not just, they can have a constant voltage applied to it. And then this timer in particular will take another source, another signal to activate the time, right? So that's just, you know, the timers get incredibly complicated when you go in actually shopping for them. Again, that's why I recommend just calling somebody. You could call Automation Direct. You could actually just call Timer Code. I originally called them before I bought that, the 619, and they walked me through the whole thing. The timer that Chris and I were messing around with last week, another one we got from the junkyard, is a coin-operated timer that runs a car wash machine. So you know, the timer, it's always powered. It has 24 volts on all the time. And then it looks for a certain amount of coins. It has to click, 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 click 8 times or whatever so that you got $2 in it. And then it'll activate the timer for 5 minutes so you can wash your car. Just kind of an interesting way to work with it. This timer, I'll show you, it's got a couple of different modes where you can set it up so that when voltage applies, it immediately starts timing. Or you have to have an external trigger switch to tell it to start. A few specialty controllers. I mentioned before the differential temperature controller, just one that I've been happy with. This is kind of the old school one, the Goldline GL30. I don't even know if they still make these. Maybe they do. But it's got 2 sensors. And one sensor is going to go up on your collectors, up on the roof. One collector is going to go down in your tank. And you can get in here and you can program what you want your differential to be. And you can tell it what you want the maximum tank temp to be. PIC controllers is something we can talk about when we look at our extruding machine. A PIC controller is, most of the time they're used as a constant temperature device. You've got a thermocouple that's measuring the temperature, and then you've got some sort of resistive heating element. And the PIC, what it'll do is open and close a relay using hysteresis to maintain a constant temperature. It doesn't know what you're trying to heat. It doesn't know, you know, you set how hot you want it to be, and it logs how long it takes to cool off or how long it takes to heat up, and it's constantly calculating how long do I need to close this relay to keep this at a constant temperature. Pretty interesting stuff. Again, that's the common DIY applications are for a constant temperature device. You can use that same PID logic, like for any kind of speed control and that kind of stuff. One that we use a lot, or not, we don't use it a lot, but we've actually found myself collecting it because we're going to be building these oil burners a little bit more here in the near future, is the Honeywell R8184N. It's looking for light. If it sees light, then it's going to close that switch and it's going to allow power, basically it's going to allow power to pass through it, okay? If light goes out, if it can't see light anymore, then it's going to have a certain like lockout time. Most of the old ones are like 45 seconds. I think the new ones are 15 seconds. Then it's going to open the circuit and it's going to de-energize everything past the controller. Okay, does that make sense? What they're using it for is in oil burning furnaces, they're looking for flame. It's a flame sensor, or it's looking for flame. It's technically not the flame sensor, but if it sees light, then it's just going to say, oh, keep going. Okay, run the fan, run the oil pump and everything. Now, if that light goes out, then it's going to assume that the flame went out. And it's going to stop pumping, it's going to stop blowing air, it's going to stop trying to ignite anymore because it's going to assume there's a problem. You know, what would otherwise happen is you would just fill up your burn chamber with oil, and then that oil may ignite and catch the whole furnace and your house on fire, right? So that's a really important controller. Okay, it's neat. You can think of a handful of DIY applications. There's one I haven't actually tried, but I read about that's, I think, pretty clever. It's a little expensive. I didn't want to buy it for the class. We don't have an immediate use for it, but when we do, we'll be looking at that. It's a Rainbird product, and Rainbird's kind of the household name for lawn irrigation or whatever. What they normally do, the irrigation controls are going to be timer-based, where you can say, cut on at 8 a.m. for 15 minutes and water my lawn. So what this Rainbird soil moisture sensor kit does is interrupt that. The lawn is already wet at 8 o'clock in the morning. It's just going to say, wet, open circuit, don't send power to the irrigation solenoid. Pretty clever. I mean, it's nice. And, you know, these systems, these soil moisture irrigation control systems can get like really complicated and kind of heady pretty quick. I like this one because it's down and dirty. It's really easy to understand. Some of the new ones will actually try to predict the weather. They'll even they'll log on, they're Wi-Fi enabled, and you can control it from your phone, or it'll look at a weather forecast and say like, I think it's going to rain in 4 hours. Don't cut on in 4 hours, right? To me, this one is just like the bare bones. It's easy to grab and understand. Some big league controllers. You guys saw the Arduino in the soldier fly bin. Arduino controllers, they're computers. They're called microcontrollers that you plug into your computer and you use their software. You actually don't use ladder logic on these. Yeah, you're going to go in and you're actually going to use computer programming in C++ language, which is a bear. What's neat about these is that they're very affordable. I think you can get an Arduino brand board for $30. They'll take a certain amount of sensors in, and then they'll have a certain amount of inputs out. If I was inclined to do so, I could replace my differential controller, and my Humidityistat, and my heating system. I could put that all on an Arduino board if I wanted to, right? And do that all for probably $100 or less if I wanted to. But it's a bear to go in and reprogram these things and to debug. And when you get multiple different things happening at multiple different times, it gets pretty complicated pretty quick, coming from a non-programmer. I'll tell you, I had a hard time, and ultimately appealed to my brother and his girlfriend for help, who are both like full-time programmers, to get my window in the soldier fly bin to know if the window was open or closed. Now, I could do that with switches. I could do that with what they call limit switches. But I wanted to basically see if I could do that without using limit switches. And I could. It's pretty neat. I'm happy to show anybody what I learned along the way doing that, if anybody's curious. If you get online and look at Arduino projects, huge network of people that are willing to help. You can have a digital signal come out and tell a relay to open or close. You can have analog signals that go out too that tell a motor to operate at this speed or not. People use these for all kinds of ranges. That original FarmBot project that we saw in the very beginning, the $2,400 CNC gardening machine, uses a board that is very similar to this called a Raspberry Pi. Just something really similar. Open source, you know, they call it open source because you can go in there and see the code, edit it however you want to. Some of the sensors that you can buy for this, huge, crazy range of sensors that you can buy, from simple, like button switches, to the temperature and humidity sensor that I had out there that you can get for like $5 or $10. I'll show you, I've got a box full of sensors right here that I'm yet to play with. This one is a soil moisture probe. Drop that in there, it does a dielectric thing where it reads the resistance in the soil. Okay, that's my SD card breakout board. So if I wanted to do data logging in that soldier fly room, then I'm already set up to do it. With the Arduino, I can plug this in and program it right, and then I can save all my data to a little SD card through this. Again, it would take me days to sit down and learn that, so we haven't done that yet. Here's a relay board. I'll pass that around if anybody wants to see that. Here's the ultrasonic distance measuring sensor that I have. But I want to use that in the soldier fly room as a counter to count larvae as they fall. And I think I can do that. I think I can set that up in the pipe, and then every time it breaks, you know, it knows that it's measuring 1 inch or whatever, and if it breaks that 1 inch, that it knows that literally a maggot has fallen through that band and interrupts it and then counts. Hopefully, I don't know, I think that'd be kind of interesting. It's kind of a pet project. They use those a lot in little like toy robots. You know, a lot of this Arduino stuff is really geared towards high school education, like high-tech high school education. Here's the big boy, the PLC, the Programmable Logic Controller. This is really the workhorse of most industrial automation systems. It's a lot like the Arduino, where it accepts a certain amount of input signals, and then it has a certain amount of outputs. And the outputs are in little relays that then go on to activate larger relays to control big loads. They're incredibly sophisticated. They can do a number of different things, quite a bit easier to program than these. This is going to program with proprietary software from the manufacturer. This Click PLC is a brand from Automation Direct that has probably the most affordable systems out there. And they have a lot of training videos. And I found that their tech support is willing to work with you. The Click, I think you can probably get that for around $300. And it's actually modular too, so you can add relays to it. I don't know how much it is to add relays to it, but the original Click will be something like this. My dad just bought a Click. He recently retired, and this is something he's always wanted to mess around with, so he's going to try to do some automation projects around his house. He's going to build a greenhouse and wants to do the, you know, raise fish and wants to be able to remotely monitor the fish and all this. So really look forward to sitting down there and learning that with him. Again, proprietary software, and it's going to use ladder logic programming. So those pictures that I showed at the very beginning of ladder logic are actually coming from a training video on how to program PLCs. The switch box, I think you can get those online for $300. Designed by a guy who flies planes. It's basically a box that has two 120-volt outlets and one 120-volt plug. You plug it into the wall, and then you control it with your cell phone. You send a text message to it and tell it to turn on. And it's a ready-made box for that application. You don't have to do any complicated Arduino to figure that out. I want to say it was $3, it could be up to $500, called the switch box. Say you couldn't make it down to check on your chickens and close the door. You could send a text message to your chicken coop and tell it to close up, I suppose. You could also use it as a block heater on your tractor if you want to start your block heater an hour early before you get there or whatever. Questions?
Great. Do you know anything about flow meters, water flow meters, and valves that you can control electronically?
Yeah, solenoid valves.
Yeah.
Yeah.
and flow meters so you know how much water is flowing. And
A flow meter is tough. Now, we used them on swimming pools all the time where it was an analog flow meter, which was nice. I could pull that up on the computer and show you later. Flow switch is, the same. It would work like any one of these other switches. Would probably have normally open or closed, just like the float switch, where if water is flowing through it, it'll click open. We got a couple of solenoids on projects that, again, they work the same way as relays. If you apply power to them, they'll open up and allow fluid to pass through. We've got a little solenoid on this system down here that supplies air to our oil burner. I had originally set up a junkyard-sourced solenoid valve to allow pressurized water to pass through pipes that we mounted on the outside of the bin to spray the sidewalls with water, just as kind of an emergency cool down. Eventually I took it off, junkyard sourced. I should have known better, but the gaskets, the seals are all wrecked and it just leaks all the time. But sure, we could buy another one of those. We ran it all last year and never had to use it. So it's one of those things we may never actually approach over. I think it was set at 95 degrees or something. Our active cooling or passive cooling system was doing the job. We want to take a look at the kiln and then come back in. We can look at these projects and I guess we can just talk after that. We're pretty much done.
What's the ambient temperature generally in that? Have you found it to be extremely hot if it's not, like if you control the temperature, like opening the door?
I think it's so well insulated that I don't know how well that passive cooling was really kicking in because we had.
It's about 84 degrees is when
It's about how hot it gets generally in it, do you think?
84 degrees is what it's set at to turn the backup fans on. I don't know.
That's
Did
right.
you explain that?
Yeah, we have fans.
Yeah, there's two 50% flow muffin-free fans in each tube.
Sure.
And that's really they're open flow so that air will still flow if they're stopped. Mm-hmm. So when it hits 84 degrees, they will kick on, and they may have kicked on. I mean, I've kicked them on purpose, but so we're ambient's about somewhere around 80.
Really?
Just even we had 101 degree temperatures out there.
Yeah, before we insulated.
Yeah. Oh yeah.
Oh, I'm sure. Yeah.
That was crazy because I had a recording thermometer for it, and I think it was over 110 inside without the insulation.
Oh, yeah.
I wrote it down. It's just a metal box. But that's a very efficient extruded polystyrene insulation, and there's an airspace between the wall and the slight airspace between the metal wall and the insulation. So that's another bit of insulation to kind of condensate track.
This actually came off of one of the farm properties that was used to control it. It was literally used to control a solar hot water heating system. It's quite a bit overkill. We actually pulled this off the wall and replaced it with a differential controller and a Renko. So we took this and probably had $250 in controls instead of this elaborate deal. But yeah, I had this at my home, trying to learn how to program it.